Hello everybody, I am Dr. Mrs. Mangal and I would like to present you video lecture on high voltage testing. I hope you have attended my first three parts on the high voltage testing. Now let us see for fourth part. In first part I have explained you the various types of the test and the different test objects, which test we can conduct and how the test we can classify. And in the video part 2 I have explained you the basics of the testing concepts, nomenclature, various specifications with which we can describe or explain the testing of bushings also we have seen, then the testing of insulators also we have seen. So I hope you have attended my previous video lectures, part 1, part 2, part 3. Now today we will see part 4, various tests to be conducted on the lightning arrestors. I hope you know about the lightning arrestor. So let us start with this. So can you tell me what do you mean by lightning arrestor? Let us do first learning by doing exercise. Can you pen down? Have you seen the applications of lightning arrestor? It is not in the course of high voltage engineering, but what is lightning arrestor? As the name implies, it is lightning and blocks the device, protect the device from the lightning. So if see this lightning arrestor is connected across the line, this is transmission line and it will be used for protections of the lines. So when lightning will fall, then whole lightning voltage will get discharged through this lightning arrestor to the earth. So this lightning impulse voltage will not transfer through the transmission lines, and whole transmission line and all the devices connected across the transmission line will get protected. So what is the function of this lightning arrestor? During normal operating condition, one terminal is connected to the line and another terminal will be connected to the ground. So only phase voltage is appearing across this lightning arrestor during normal operating condition, and this phase voltage is not sufficient to pass the current through the lightning arrestor. So this transmission line current will be passed from one end to the another end. Suppose power is transferred from this end to the another end, there will be no current through the lightning arrestor. Of course leakage current will be there, but this power current will not transfer through the lightning arrestor, because in that case arrestor resistance will be very high because voltage is normal. What is the voltage? Phase voltage. So this is the line and second terminal is connected to the ground. So this phase voltage is the normal voltage, and resistance offered by this lightning arrestor is very high because it has the characteristics of non-linear resistance. If voltage is normal, resistance will be high. But when lightning appears, now the lightning has very high voltage. So when voltage becomes very high, then resistance becomes less. So the resistance of the lightning arrestor get drops, and due to the non-linear resistance characteristics, in case of voltages, whole the charge will get discharged to the earth. So this is how the lightning arrestor protects. Now when you carry out the testing of this lightning arrestor, you have to see how much is resistance offered, what will be the leakage current, what will be the voltage drop. So let us see various tests to be conducted on the lightning arrestor. So lightning arrestor is made up of this disc, lightning disc. You can say number of discs will be stacked one above another. And when you are testing lightning arrestor, you will test disc by disc. So let us see what test will be conducted. So first test, let us see voltage and ampere, VI characteristics, volt ampere characteristics of the arrestor, which will vary with the temperature. You know, if the temperature is varied, the resistance of the insulators, conductor gets varied. In case of insulator, your resistance will get dropped down with the temperature, and in case of conductor, it will goes on increasing. So these characteristics you know. If the temperature of the arrestor is raised, then the leakage current through it also raised. Why? Because resistance of the insulation will get reduced, and as the resistance will get reduced, current will also increase. And you have to check this leakage current, because during normal operating condition, current through the arrestor should be limited. It should not be increased. So this VI characteristic is considered in the testing. When the lightning surge is discharged through it, then the temperature of the block increase. Hence the temperature is considered into account for considering VI characteristics at the various voltage. Means you can plot these VI characteristics at different temperature. It is necessary to find out performance of the arrestor blocks. As already I told you, it will be tested in blocks, different stacks. It will be taken and then it will be tested at different temperature levels with different dielectrics such as air, transformer oil and SF6 is necessary. Means you can carry out this test with different insulating materials, air, transformer and SF6. Then second test is reference voltage test. What is the reference voltage? When voltage across the arrestor block means one disk is 1 milliampere, means when voltage is applied across one arrestor block such a way that current through that disk is 1 milliampere, then that voltage is called as reference voltage. So reference voltage, you can say in short, when 1 milliampere current is passed, voltage drop across the stack or one block, it's called as reference voltage. And this reference voltage is tested because again voltage should not be very high. If voltage across one block will high, then whole voltage across the lightning arrestor will increase, and that will also cause the resistance characteristics dropping. It is not desired during normal operating condition. So reference voltage is also tested. The test in different media, air, transform oil and SF6 is carried out with the dielectrics at various temperature. 30 degree to 120 degree Celsius is considered, and the voltage across arrestor is measured and calculated. Now resistance at 1 milliampere and 4 milliampere is also calculated if you are interested in calculating the coefficients beta. So this is the characteristics. You can see resistance is plotted and temperature. When temperature is increased, resistance of the arrestor is going on decreasing because it is a insulator, and different air materials you will get different characteristics. And 1 milliampere you can find out the reference voltage also from these characteristics. Second, next test is accelerated aging test. Now name only implies it's a aging test, means how much your disk or lightning arrestor block has aged, means degraded. And then accelerated means you will purposefully create the aging and then you will check it how much aging will occur and what will be performance of this arrestor block if aging will occur. So according to the IEC 1994, the aging test can be conducted at minimum operating voltage. So minimum operating voltage at temperature 115 plus and minus 4 degrees Celsius tolerance is given, and temperature means this time duration is 1000 hours because you are conducting accelerated aging. So whole 1000 hours you will apply the voltage, minimum continuous operating voltage, and you will see how much arrestor blocks will aged or will get degraded. Then at the rated voltage of the arrestor block, the watt losses are measured after the aging, because when aging occurs then this power loss can increase, so you have to check it, and the results is compared with the watt losses before the aging test in different dielectric material, because during normal operating condition your arrestor should not cause high power losses. That is the intention of this test. Next test is residual voltage test. Now what is the residual voltage test? When 1 milliampere current was passed, voltage drop was called as reference voltage. But here when rated current will be passed, see, as per the IEC 1994, when rated current is passed through the blocks in 3 insulating media test cells, then the temperature of the blocks is to be maintained and measured the voltage across the test cells. Means residual voltage is the voltage across the arrestor blocks when rated current is passed through it. The practical values of residual voltage of ZNO blocks at different voltages found out. Next test is current impulse test. It is used to check the integrity of the silicon carbide blocks. Means the arrestor blocks, in case of silicon arrestor, it will be made up of silicon carbide blocks. So when arrestor block is taken and then the comparison of the waveforms, because you are conducting current impulse test. So comparison of the waveforms with different impulse current will be considered produced by the arrestors will be checked and performance will be tested. So this test is conducted under the more than usual quantitative measurements. Means more than usual means when its rating is there, you have to apply some higher ratings. So higher than the actual quantitative measurements. The inclusion of both AC DC leakage current measurements serves as twofold purpose. Means when you are passing current impulse through the arrestor, you can pass AC and DC and find out the leakage current, because when normal voltage you are applying, current passing through the arrestor will be called as leakage current. Next test is failure impulse testing. The function of arrestor is to limit the amount of voltage rising across the device. It is protecting when subjected to voltage arrest over stresses, means over voltages. That's already I told you. So in failure impulse testing, you can test it with the 100% waves, means superior arrestor performance is characterized by consistent impulse spark over at lower impulse voltage levels. Means lower impulse voltage you will give and spark over voltage consistency you will find out. This measurement offers a more effective comparison with the maximum standard lightning impulse spark over voltage, and 100% guaranteed impulse spark over voltage you can find out. So failure impulse testing, of course, whatever is the normal rating of the arrestor, it will fail at over voltages. So you have to find out it at what voltage failure will take place. Then leakage current measurements. Already I told you what is the meaning of leakage current. So the test is commonly used and often effective measure of integrity of arrestor's internal components, means performance of the arrestor's material. It is particularly useful for determining the condition of the arrestors that do not contain resistively graded gaps, as the only connection between spark gaps electrodes is insulations. Means see, some arrestors have nonlinear resistance and in series with the gap. So when gap is there, gap resistance is also there. So you have to find out whether it is taking higher leakage current or no. A low value of resistance would indicate significant internal corrosion. Means leakage current should be low. So you can say that internal corrosion is very less. But if aging occurs, this current will be higher. The next test is AC leakage current test. So AC leakage current measurements are more commonly used as diagnostic tool for metal oxide, because this is a type of arrestor. Surge arrestors, where it accurately measures of the resistive component of the leakage current. So AC leakage current test will be conducted mostly for the metal oxide types of arrestors. So this is the circuit for measuring AC leakage current test. So you can connect test object here. You can generate very high voltage supply, limit the current through it and pass through it and measure this current, because when you are measuring resistance, you have to measure voltage and current, and then you can use this voltage divider to measure the voltage, because voltage will be very high. So measure voltage and current and then find out the resistance. Now cable testing we'll see in the next part. So I hope that you have liked this video. You have to prepare for the oral discussions also. Now reference book which I have referred for this video lecture is British Standards High Voltage Test Techniques by Dieter and Kind, which is a very good book for the testing. And this is general books, Kamroja and Naidu. And this is my own book also I have referred, which is authored by Chaudhary sir also and Sava Sheikh madam also. So I would like to say thank you. So